Hello, my name is Cameron Davey, Partner Solution Architect at Talend. Today I'm going to talk to you about moving trusted data at speed into AWS with Talend. Talend puts more data to work for businesses with the same budget. Talend uses a subscription-based licensing model, meaning you acquire a subscription for the Talend components you will be using and the number of Talend users in your organization. Unlike others in this market, we do not charge extra for the number of connectors you use. We come with well over 900, and there are no charges based on the amount of data that your team is working with. This means that you have a predictable pricing model for your data integration projects with no surprise added charges. If your team of 3 is working on a project that requires 5 connectors and involves 5 petabytes of data, you pay no more than if that same team's next project involves 75 connectors and 20 petabytes of data. Talend is an advanced tier technology partner in the AWS partner ecosystem, certified on the AWS Big Data Competency. Talend and AWS have thousands of mutual customers, and our partnership and joint customer wins span the globe. Of course, for many years, Talend has been able to build data integration and big data processing jobs for AWS services. With Talend, you can deploy jobs connected to compute, storage, processing, and data warehousing services all across AWS. In addition to that, Talend itself is deployed on AWS for its own cloud hosting and computing needs. This includes Talend Cloud and its related cloud apps, Stitch Data Loader, and our new Talend API services. The data ecosystem grows bigger and more complex every day because of the multiplication of data sources and the growing demand for more actionable data for all lines of business. As the growing demand spreads across the entire business, it is more important than ever before that both IT and the business users trust the data that is being delivered, and that this trusted data is delivered at the speed of business. Talend provides the capabilities to connect to all of a company's sources of data, to ingest that data, to clean and transform that data, and finally to deliver and share that data as required. All the while, Talend provides the facilities to govern that data through the ingestion and integration lifecycle. With AWS as the compute, storage, and processing backbone for an organization's data needs, Talend fills the air gap by integrating directly with AWS to deliver governed, trusted data as quickly as the business needs it. Talend delivers connectors and configurations for all of the most popular AWS services. From storage to data services to compute, Talend provides out-of-the-box connectors across all manner of AWS needs. Our demonstration today will focus on 3 of the most used and most popular AWS services: S3 for storage, Redshift for cloud data warehousing, and EMR for processing. So what are the primary use cases for using Talend in conjunction with AWS? First, there is the need to build and fill a governed data lake. Talend easily helps businesses connect to source systems and collect that data to populate data lakes. While moving that data into data lakes, Talend cleans, transforms, catalogs, and governs that data so that users can absolutely trust the data that they are reading in their data lake. There is also the need to modernize data warehousing projects. Just like with data lakes, Talend can ingest, clean, transform, catalog, and govern the data as it moves into AWS data warehouses such as Redshift. And for those high volume needs, Talend provides a codeless interface to build Spark jobs that will run natively in EMR. Data engineers can take advantage of new and emerging technologies without writing a single line of code to develop high-impact Spark processing jobs. 3 examples of customers that have truly liberated their data with Talend are Johnson Controls, who dramatically increased their development speeds, AstraZeneca, who significantly lowered costs, and Lenovo, who realized a double-digit increase in sales revenue. Their full customer stories can be found on the Talend website, www.talend.com/customers. Now let's take a look at the demo, which will show Talend connecting to AWS S3, Redshift, and EMR. Here we are in the Talend Studio. This is our design interface for building our jobs that will run within the AWS environment. On the left-hand side, we have our repository, which is our collection or library of all of the jobs and preset configurations that we have. Within the job designs is where we have our library of all the jobs that we've built in the past, connected together with all of the people that I have in my work group. And then down below is our metadata repository, which is where we save and store all of the information that we have preset, such as our preset configurations into Redshift, EMR, S3, etc. On the right-hand side is our palette, and the palette is where we keep all of the information on the components that we have in Talend. So in our case, we have over 1,000 components that you can add in here. And of course, we've highlighted the Amazon components here. So all of our connectivity components for Aurora, for instance, for EMR, for Redshift, for S3, etc. So you can simply take one of these components and drag them on to the canvas to build out a job. And you can see an example of a job here. And in our demo here, we have a series of jobs that we have created, starting from the most simple job, which is simply taking a CSV file and logging that out to an on-screen display. We've mapped two different CSV files together to create a result set. In this case, we are putting the results finally out into an S3 bucket using the put command. In this case, we are doing that same example, but we're getting the original file from S3 and then doing some mapping onto it and then putting that out to our S3 bucket. And then finally, we have this example here, which is where we'll start. So in this example, we have established a connection into Redshift using our DB connection object down below. So you can see that I have my configuration down below for my Redshift cluster. I have located two files that are coming from my local file system in this case. So I'm picking on-premise data up, if you will, and I'm going to put this data up into my AWS cloud. I'm going to map these two together to create a result set, load that information into the cust orders table in my Redshift data source, commit that information, and then close it out. So in order to do that, I simply come to my Run tab on my job, hit Run, and that job will execute. And that job is executed to load all of my records, in this case 9,999 records, into my Redshift cluster. If I take a look at where that information was stored, I can load that up again. You can see it's coming to the cust orders table. So if I come over to my Redshift console, I can change the query here to show that I actually ran all of these rows and loaded them into the cust orders table in my Redshift cluster. There we have it. Coming back to our jobs now, I can come to the next order, which is to take these files, load that connection, and put that into an S3 bucket. And the purpose of doing that is to show that we actually have a further capability within Talend, which is to use the bulk execution. So what I can do in this example, what I'm doing in this example, is doing the same process of loading these files. In our case, we're bringing the files off locally. So we're picking data up off of local file system to do an on-premise lift and shift, if you will, of data, loading that, creating a mapping of that data, putting that into an S3 bucket, and then doing a bulk execution of all of those rows into my Redshift cluster. So again, all of that information exists down below, down here. So I can come over to my run command, clear this out, and run that. So again, what it's doing, taking that data locally off of my file system as an on-premise lift and shift, and then loading that data in a bulk exec process into my Redshift data source, and it's already completed. So it's a very fast process to be able to do a bulk execution of those rows directly into my Redshift data source. And in this case, we're loading it into a new table. Our cust order is new. So if I come back over to my Redshift query interface, I can just change this to new, run that query, and it will show me all of the results, the records, if you will, of loading that data into my Redshift cluster. So I was able to successfully run that job, which is great, but all of this is taking advantage of the local resources on my machine in order to process this information. What I really want to do is I really want to process this information in a truly SaaS environment without any processing really done locally on my own machine. So in order to do that, I want to take advantage of Talend Cloud. Talend Cloud is the SaaS offering of being able to publish and promote these jobs without having anything running locally on my own machine. So in order to do that, I would upload this job up to Talend Cloud. So to do that, I've located the job within my repository, and I right-click on that job and I say Publish to Cloud, and that will automatically use the credentials that I've located in order to publish that information directly to my Talend Cloud account. I've conveniently located my Talend Cloud account where I have logged in, and I'm going to come over to my management console where I have uploaded this job. There's my AWS bulk exec job that I have already uploaded. So to run that job, I simply click on it, and I'm going to give pass in any available parameters that I need to do. Once I've done that, I'm just going to run the job. Now you can take a look at the outline of the job. It takes a screenshot as it uploads it, and you can see that it's my job, right? Mapping those files together, using the put command to put that into the S3 bucket, and then doing the bulk execution. So if I do that, I simply come back over here and I can run that now. So as that job runs, again, rather than having to use any resources locally, it's running that using the Talend Cloud account, which runs it is completely built on AWS today, and runs that job within the Talend Cloud parameters. And you can see there that the job was successfully run. So now, without having to have anything running locally on my own machine, I was able to run that job within Talend Cloud. All of the jobs that we've run previously in this example, in this demo, have been using Java as the processing engine, if you will, but we want to move a lot of data. So in order to do that, we're going to use Spark. And in our case, we're going to use EMR as our Spark processing engine. So this last job that I have is going to use Spark as our processing engine here. So for this job, it's very simple. We're picking up some data. In fact, it's all done in the cloud. So we're picking up data out of an existing S3 bucket. We're aggregating that data. We're sorting that data. We're masking some of that data and then creating an output. And we're doing all of that using Spark processing. So I have my preset S3 configuration in my bucket. I have my HDFS information for where that information is stored within for processing. And if I come into the job settings itself, I have all of this information preset as to what my EMR cluster looks like and how it's going to process. So that's all done on a single setting page within Talend. Set it once, and that is already completed. So all we need to do now is run the job, and that will again take that job out of my existing S3 bucket, do this Spark-based processing for aggregation, sorting, and data masking, and then output that file. So if we take a look at where that is, that's going to write that out to the specific file in my existing S3 bucket. So I would come over to run, and I'm going to go ahead and run that job. Okay, so that job has successfully completed, and I can see that because it's given me an exit code 0. And in order to test that, you can see, first of all, down at my time clock over here, it's Valentine's Day, 1:09 p.m. Pacific time. If I come over to my S3 bucket, here's where that information was stored. If I scroll down to the bottom, here is that cust XXX test file that I created, and you can see that it was created Valentine's Day, 1:09 p.m. And that is exactly what we need to do. It created that file. It did that using Spark processing and was able to send that information directly to my own S3 bucket. So in fact, everything was saved within my AWS cloud information. Pulled that information out of my S3 bucket, processed that using EMR, loaded that file back into my S3 bucket, and completed. Thanks for watching today's demo. For more information, please visit talend.com.